Hello students, welcome to another session of Grade 9 Mathematics, Chapter 1 Number System. In today's session, we are going to deal with operations of real numbers. Before we actually get into the questions to understand it better, let us discuss why is this topic important. My dear students, if I would have asked you what is 5 raised to the power 2, it would have been simple. 5 raised to the power 2 is basically equal to 5 into 5, which is 25. Say, if I would have asked you what is 6 raised to the power 3, 6 raised to the power 3, it would have been simpler again. The answer would have been 6 into 6 into 6, which is 216. But what if the power is not a whole number, but is a rational number given in the form of P upon Q? For example, you have got the question as 125 raised to the power 1 upon 3. I say it again, the question would have been 125 raised to the power 1 upon 3 instead of the power 3. So here we are going to deal with questions wherein the power is in the form of rational numbers in the form of P upon Q. Let us understand how and what are the operations that would be required to get to a solution of such questions. Let us understand the concept of laws of exponents for real numbers by solving a few questions from the NCERT textbook. We will be solving exercise 1.6. Let us solve the first question. Now, here we have been asked to find the value of 64 raised to the power 1 upon 2. Over here, you can observe that the power is in the form of P upon Q, which is 1 upon 2. Now, the understanding to this sort of concept is to get rid of the denominator in the power. See, if the question was 64 raised to the power 1, it would have been easy to solve. But the denominator is actually stopping us from solving it the easier way. So the understanding is every time you have to get rid of the denominator in the power. So what I would do next is 64 I know can be written in the form of 8 raised to the power 2. Now you may say, sir, 64 can be written as 4 cube also. But I would prefer writing 8 raised to the power 2. Why so? Because when 64 is written as 8 raised to the power 2 into the power remains in the question. So 2 gets cancelled out and I get 8 raised to the power 1. Since I have to get rid of the denominator in the power, I wrote 64 as 8 raised to the power 2. So on solving, I get 8 raised to the power 1, which is 8 itself. Let us understand this concept by one more sum. Say, the question is 32 raised to the power 1 upon 5. So what are we supposed to get rid of? The denominator in the power. Now, on prime factorization, you will realize that 32 can be written as 2 raised to the power 5. So 32 is written as 2 raised to the power 5 into the power of the question. So 5 gets cancelled out and what are we left with is 2 raised to the power 1. So 2 raised to the power 1 is basically the number 2 itself. Let us understand the concept with a few more questions. Let us get to the next question. Now this is what we have discussed as part of example in the beginning. And the question was 125 raised to the power 1 upon 3. Now, what am I supposed to get rid of? The power, the denominator in the power, which is 3. And on prime factorization, I know that 125 can be written as 5 raised to the power 3. So 125 is written as 5 raised to the power 3 into the power in the question. 3 gets cancelled out. So what I get is 5 raised to the power 1, which is 5 itself. Let us further understand it by solving the question number 2 of the same exercise. Here we have been asked to find the value of 9 raised to the power 3 upon 2. The concept remains the same, is to get rid of the denominator in the power. So 9 can be written as 3 raised to power 2 into the power of the question. 2 gets cancelled out. So what do we have? 3 raised to the power 3. And 3 raised to power 3 can be written as 3 into 3 into 3, which is 27. Let us get to the next question, which is 32 raised to the power 2 upon 5. So what is the power over here? 2 raised to the power 2 upon 5. And what are we supposed to get rid of? The denominator in the power, which is 5. So on prime factorization, you will realize that 32 can be written as 2 raised to the power 5 into the power in the question. 5 gets cancelled out. So what are we left with? 2 raised to the power 2. So 2 raised to the power 2 is basically 2 into 2. 2 gets multiplied twice, which is the answer is 4. The next question over here is 16 raised to the power 3 upon 4. As always, as we did with the previous question, what are we supposed to get rid of? The denominator in the power. So 16, yes, it can be written as 4 raised to the power 2. But we would prefer it writing as 2 raised to the power 4. That is 2 into 2 into 2 into 2. 2 raised to the power 4. Why? Because we want to get rid of the 4 in the power, with the 4 in the denominator of the power. So when 16 is written as 2 raised to the power 4 into the power of the denominator, the 4 gets cancelled out. And what do we get is 2 raised to the power 3. So 2 raised to the power 3 basically refers to 2 into 2 into 2, which is 8. Let us get to an interesting next question. This is where students may get it wrong. The concept remains the same. The question is 125 raised to the power minus 1 upon 3. So here our power has a minus sign. The concept remains the same, is to get rid of the denominator in the power. So I know 125 can be written as 5 raised to the power 3 into the power of the question, that is minus 1 upon 3. And here the 3 gets cancelled out. So what am I left with is 5 raised to the power minus 1. And we have learned in our previous grades that to get rid of the negative power, what we can do is the reciprocal of the number itself. So in the next step, we carry out the reciprocal and we get 1 upon 5 raised to the power 1. For here, you will realize that, you will observe that the negative sign of the power has been taken care of. So we have 5 raised to the power 1. So the final answer would be 1 upon 5. I hope you're clear with these concepts. Let us try to understand real numbers and their operations with the next few questions. Now, let us solve 3 more questions of this exercise and try to understand in a better manner the operations of real numbers. We'll proceed with the same exercise, question number 3, which is simplify. Now, here the first question is 2 raised to the power 2 upon 3 into 2 raised to the power 1 upon 5. Now, here you may observe that 2 is a common base. And we know that when we multiply two numbers having powers, when the base is common, and since there is a multiplication sign, what we'll do is we actually add the powers. So the base which is common is written once, and the power, that is 2 upon 3 plus 1 upon 5, is added. And you can see over here, when they get added by taking the LCM, the answer happens to be 13 upon 15. So the answer is 2 raised to the power 13 upon 15. Let's take the next question. Over here, you will observe that the question is 1 upon 3 raised to the power 3 whole raised to the power 7. The question over here is very simple. All that we are supposed to do is open the bracket. And when I open the bracket, the power 7 goes with the numerator as well as with the denominator. So 1 raised to the power 7. And over here in the denominator, we have 3 raised to the power 3. The 7 gets multiplied with the power over here. And we have 1 upon 3 raised to the power 21. 21 is obtained from 3 into 7. Let us take one last question for understanding the operation of real numbers. The question over here is 11 raised to the power 1 upon 2 upon 11 raised to the power 1 upon 4. If you correctly read the question, it could be read as 11 raised to the power 1 upon 2 divided by 11 raised to the power 1 upon 4. As in the first case, in the third sum also, the base is the same. Here, the base is 11. And since we have the division sign, what can be done is the powers can be subtracted. You'll observe here the subtraction of 1 upon 2 and 1 upon 4 give the answer as 1 upon 4. So the final answer is the base remains the same, that is 11, and 1 upon 2 minus 1 upon 4 solved gives us 1 upon 4. So the final answer is 11 raised to the power 1 upon 4. By this, I hope that you have understood real numbers and their operations.
My dear students, let us learn today how to represent under root 9.3 on the number line, or under root any number x on the number line. The method would remain the same. Now, the very first step of part of representation is to draw a line segment which is equal to the length of the number given under root. So here the number that I have to represent is under root 9 by 3. So I'll begin with drawing a line segment which is actually measuring 9.3. So this is 0 and here I have 9.3. So I'll draw a line segment of 9.3. Let me label these endpoints. Say this is A and this is O. Now, if the number was under root say 6.5, I would first draw a line segment of 6.5. Since here it is 9.3, I drew a line segment of 9.3. The next step, the second step, is to extend this line segment by 1 centimeter. So irrespective whether it is 9.3 or 6.5 or 7.2, the second step remains the same. Only in the first step, this number is important. I've extended this by another 1 centimeter. Let me name this point B. Coming to the third step. The third step is wherein I'll try to make a perpendicular bisector of AB, the entire line segment that I have made. So, using my compass, what I will do is take more than half of the entire length. So this is more than half, and make an arc on either side of the line segment from both the points. Ensure that the arcs are intersecting each other. Now, what I will do next is, I've got the perpendicular bisector. I'll draw a line through it. So this gives me the midpoint of the line segment AB. Let me name it M. Now, let us recall the first three steps. The first step was to make a line segment that is equal in length of the given number. So 9.3 was under root. We took 9.3 as a number and made a line segment AO which is equal to 9.3 centimeter. Then what we did was extended the line segment with 1 centimeter. Then we took the entire line segment and made a perpendicular bisector of the entire line segment, that is AB, and got the midpoint M. Coming to the next step, wherein I'll keep M as a center and measure A. Or I can measure B. They have to be the same because M is the midpoint. Now what I will do is I'll make an semicircle sort of thing, as you can see over here. So taking M as the center, I made a semicircle using the compass. Now coming to step number 5. Step number 5 is wherein I'm going to make a perpendicular line from point O. Now say I keep the protractor over here. Make sure the baseline is correct and mark my 90 degree. And then coming to the next step, I'll use my scale and draw a perpendicular line from O. Yes. So I've got a perpendicular line. Now you'll observe that this perpendicular line drawn from point O actually meets our arc at a specific point. Let's say this point is C. Coming to the last few steps, all what I'm required to do is use the compass again, keeping O as the center, measure the length of OC. Yes, and then draw an arc. If you could see over here, I drew an arc. Okay, now the last step is to extend this and make it a number line as it is required in the question. The point where the arc of OC met the number line will be called under root 9.3. And we know that this was the initial point. So this is 0, 1 centimeter was taken from here. So this is 1. And this point is actually the length of under root 9.3. You can cross check this because we know that under root 9, which is less than under root 9.3, square root of 9 is basically 3. So this point has to be more than 3. Yes. Now, I hope you have understood today's session. Kindly practice it again with a few more numbers, such as under root 7.2 and so on. Take care of yourself until we meet next time with another session. Thank you.